guys, it's Mrs. Dewar. Today's video is on zeros of functions. We're going to look at this two ways. We're going to look at zeros of functions graphically and algebraically. We'll start off with graphically because it's visual and you can actually see what it is you're finding. So given a graph, the zeros of the function are the x-intercepts. Here's an example. We've got a graph here, we've got a continuous function, so a straight line. And you can see that this line hits the x-axis, here's the x-axis, right here at -2. So that makes the zero for this function -2 because it's where it intersects the x-axis. Now let's look how we do this algebraically. So algebraically, a zero is an x value for which the f of x equals 0. Or remember from the last video, f of x is the same thing as y. So in other words, what is x when y is 0? So to figure that out, you replace the f of x, or the y, with 0. So you can see f of x became 0, and the 2x plus 4 is still 2x plus 4. And then we just solve it. Subtract 4 from both sides, divide by 2, x equals -2. So I'm going to put these side by side now. Graphically, you can see we got -2, and we took the same function and we did it algebraically, and we also got -2. So just two different ways to look at it. Now, note that zeros of functions are also called solutions. So a function may have one solution, two solutions, or no solutions. If it's got two solutions, it may look like this here. This has got two solutions because this is a parabola and it comes down and it hits the x-axis here, and then it dips down and it turns around and comes back up and hits it again. So it hits it at two places, and so therefore we have two solutions or two zeros. Something like a straight line is only going to hit it one time, and that means we're only going to have one zero. And this is an example of no solution. This parabola will come up, it will top out right here, and it will come back down again. It will never hit the x-axis at all. So that means no solution. So what we're going to do is solve this function graphically and algebraically, and we'll see that we should come up with the same answer. Graphically, what I want to do is make a solution table. And you can pick whatever you want for x because we weren't given a defined domain. So I'm just going to use 0, 2, 4, and 6 because I'm noticing up here that I'm going to be cutting x in half. So I picked even numbers to make that easier. So putting in the 0, we get half of 0 is 0 plus 1, which is 1. If I use 2, half of 2 is 1 plus 1, gives me 2. If I use 4, half of 4 is 2 plus 1. And if I use 6, half of 6 is 3 plus 1 is 4. So you can see we kind of just plotted those along the way, and this is just a sample of points. This is what we got when we used 0, 2, 4, and 6, but we know the domain is not restricted to those four numbers, so therefore the graph will consist of everything beyond those as well. Now remember what we're looking for here. We're looking to see where does the graph hit the x-axis. The graph hits the x-axis one time right here, and that happens to be at -2. Now if I want to do this algebraically, I will replace the f of x with 0, and I will set 1/2 x plus 1 equal to 0, and I will solve. I'm going to subtract 1 from both sides, and divide by a half we don't normally do because it's a fraction. Instead we multiply by the reciprocal, which is 2, because that will cancel out your 2 and your 1/2, leaving you just x. And on the other side, -1 times 2 is -2. So I did it algebraically, and I got the same thing as when I did it graphically. So that's it. Hope that made sense. Don't forget to like and subscribe. If you're interested in the unit that goes along with this video, just click the link below. Thanks for watching.